Welcome back, mechanics. Today we will be trying to make a combination lock out of buttons. To make a combination lock out of switches is probably one of the easiest things you can make in Scrapmechanic. In fact, I'll demonstrate it right now. If I want this combination to just be an X, all I have to do, all I need is an AND gate and a NOR gate. So put the NOR gate into the AND gate. You look any switches you want off into the NOR gate. Then just hook any switches you want on into the AND gate. See what? Two logic gates? That is a very simple combination lock. But coordinating our buttons will be harder. And once I've done that, I do want to integrate it into this hidden vault build. When you open the build, open the vault, see, we'll open the sequence. The gold is here, but if you were to, I'm gonna disconnect so I don't go straight to that again. Get the code wrong, the door would come back, and that would be hidden away. So if you broke in here, the gold would be gone. So I want to now make a button combination lock to integrate into this, and hopefully make it order sensitive, which is not the case for this switch lock. So let's get through. Alright, so to get started with this, first I just want to build this little panel, which will be the base, which will be encoded. So this is our input panel. Now, I've never built anything like this. So you'll be seeing me working through all these circuits for the first time. First guy I will build is a memory circuit. Now, each of these buttons probably need ones. I probably would need 9 of these. These are pretty simple to make. All they are, it's going to be a NOR gate going into AND gate, and this button goes into, and so then the input goes into both the NOR and AND gate. The AND gate goes to these 3 gates at the top, which are a loop of XOR gates. Here, because I forgot to next one in. A very simple memory circuit. Where do we go? So now for this next memory circuit, I will only want this one to be able to enable if this previous one is already on. So, like that. AND gate, go to there. Now this, alright, so we're gonna have to wait till this is on. But then, I do want it, so if I press in the wrong order, now this should turn off. So if this is, yeah, this should work though. Yeah, it should work. And if this one turns off, while this one's on, you also want this one to turn off. So, that means we want to change this from an AND gate and change this one to a OR gate, which this one is off, and this one is on. Then wanted to turn that off. Here. This one needs to be, yes, this needs to be changed into E. So now we can turn that off. Also, going to turn that off. Else turns this circuit off. And so we probably want that as a repeating pattern for the sequence of buttons we have. Until we need 9 of these circuits. So I will come back once I've built all 9 of them. Okay, so after doing some testing, I realized that you would only need these circuits for the amount of correct button press you have. Because if we have our code as 1, 2, 3, all the rest of these, you just need to turn all of these off once they are pressed. Now, one problem we have the circuit right now, I can see, I can just unpress this, press this again, and press this again, which would be the wrong combination for the circuit. So now, that fixes that problem. Fix that. If this is on, I press this again, that turns that off, but I should also turn this off, which means this also needs to be hooked up into an OR gate. So this should only turn on if all the rest of these, well no, that doesn't make sense, because this would only ever toggle. So this can only ever toggle to the on, so that's not what we need. We need it so that if this is, so this is on, this is off, this turns off. And this is already the circuit, so we just hook the output of the circuit into this OR gate. So let's fix this problem. But you could still double click that then, which again still would not be the right combination for this. So to get this off again, we need some way of turning the rest of these off. I really don't want to make another memory circuit for this, because this is, I want to try to keep this circuit small if possible. That's interesting, that ripples through and turns that back on. That's all? Yes, because this turns off first, that means this will be off, this will be on, so that toggles this back on. It's interesting. We don't want that to be able to happen. But I'm not sure how to prevent that. For now, I will just hook in the reset button, the reset logic for all the rest of these buttons. So for a combination, this one will simply be 1, 2, 3. So the reset logic for this should be simple. Hook all of these into an OR gate. Then each of these need an AND gate. So we should already, no we're not. See, because now it's in an OR gate. So we're just gonna hook up the reset button separate. An OR gate and an AND gate for the reset logic. And I will paint this separately red. Hook this OR gate into all the AND gates. An OR gate should go into all of these. I am wrong actually, this should not be a NOR gate here. These should just hook directly into the AND gate. I press any of these other ones. this logic now needs to go into... Where's the OR gate for this? This is the OR gate? Yes, okay, so this needs to go into the OR gate. All these go into the OR gate, and so now if I press any of these, that all turns off. Have it something like... I have that off too. This, all of these should turn off when any other button is pressed. So right now, this will support the combination of 1, 2, 3, 3, 3. So, one way we can prevent this is that once we get this lock in, this cannot turn back off unless this is off. No, that's not how we do it. Then how do we stop this from happening? We could add delay. That these two switch at the same time. So where is the gate that turns this off is here. So instead of connecting there, we add a timer. Do 2 ticks of delay. That should hopefully fix it. Turn all of these on. I turn that off. Still fix it. I guess that's not going to the right thing. This should actually be where should this be? We should be between the NOR gates. And that fixes that problem. We reset the lock to that state. Now press this. So I press this button, and this is on. I wanted to reset that. So that resets now. Yes, okay. And now, the thing is with this button makes it hard is that there's no logic gate that should be off when there's no memory that should be off once that is on. I think I'll leave for now. It's not that big of a deal. I might try to work on this a little more so I can get this working, but this, so far, it's a pretty small circuit. It only uses 3 logic gates for a 3-digit code. So I will color the gates, make the circuit I'm using more clear, and then I will try implementing this on the actual door. 3, 2. Okay, so I've colored from the gate, so all this red stuff, all the red gates, deals with all these incorrect inputs and reset the circuit. In fact, I'll hook up another button to it, which is just a reset button. All the green log gates are all the memory circuits. These are the outputs. Then the blue gates are the inputs for the circuit. So I've hooked it up to this door. So all this is an AND gate. I see signals from all these outputs. So when I press this, and these are all on, it opens. Actually, the next thing I did want to do, but guys, there's no way to close it. This would be an AND gate. This should actually be enough. Yeah, it should be an AND gate and an OR gate connected into this. And so then the reset button should not connect directly to the OR gate. When it's closed, that should go into another AND gate. Which I got the OR gate. So now that the reset button will also close the door. There's another one implement that is if this is pressed and this will also be part. So I'll reset circuit stuff. But this is pressed and one of these is off. This will go back to reset the button. So if I just go 1, 2, and then I press this. Why isn't it working? Oh, I think I went in. That's an AND gate then. I get to the wrong gate into the reset. This should be the new reset. Okay, so if I do that, and then I press that, so I have the wrong combination, it just resets it. So that is an order-sensitive combination lock with buttons. So I'll put this logic into my volt, and then we can do the final showcase. Alright, I have put the circuit up into the volt. You can see I have the circuit here. This purple one is going to be your open circuit. So once that's on, that means combination is right, the button was pressed, and your door should be open. And then of course it's off, your door should be closed. So that's where you want to hook your output in. Out to. So the code for this one is 1, 2, 3, open. And there we go. This should be an expandable design. You should be able to do it with a 3-number combination or with like 50 numbers. Of course, reset circuit. Just resets everything. To demonstrate, that only works one way. Wait. This is a input circle, I just realized. Is that... Okay, ignoring that. 3, same numbers, that's that, doesn't work. 3, 2, 1, doesn't work. I pressed all of these, even though I did press these ones in the right order, because I pressed one that wasn't in the circuit. It's wrong. All these are off. I do 1, 2, 3, 3. Doesn't work. Oh, that worked. Why did that work? Really, it's not that better for me. I don't know why that worked. I would need to review footage. I might have just accidentally put in the right combination. So that is it for this video. In our next video, I will be teaching you how to build an elevator in Scrapmechanic. Thanks for watching. Goodbye.